Lesson 49, we're going to introduce solids in geometry. Now what a solid is it's basically a three-dimensional figure. We have been having squares, circles, different things like that. Those are two-dimensional figures, and so those are not solids. So I'm going to show you different examples of solids. All these fall under that category. The first one is a polyhedron. Any closed three-dimensional figure formed by four or more polygons that intersect only at their edges is called a polyhedron. Now, I try to draw a cube here, but this also has another name, and that's a prism. A prism is a polyhedron formed by two parallel congruent polygonal bases. So this is actually an example of both. There's different types of prisms you could have, but the main thing is if I have, say I have a triangular base on the top, my base on the bottom must be the same, and these are all parallel. But that's a prism. The next shape we have is a cylinder. And a cylinder is a three-dimensional figure with two parallel circular bases and a curved lateral surface that connects the bases. So, cylinder has two circular bases. A cone has one circular base, and it meets at a vertex. It's got a curved lateral surface, but it all comes to a point. That is an example of a cone, and then a sphere is the set of points in space that are a fixed distance from a given point called the center of the sphere. So the center is kind of right there, and everything's kind of orbiting around it. But sure, think of a basketball, soccer ball, things like that. And then the last figure we'll talk about, the last solid, is a pyramid. What a pyramid is a polyhedron formed by a polygonal base and triangular lateral faces that meet at a common vertex. So no matter what your base is, here it's a triangle, three sides, and here we have a quadrilateral, four sides. But notice that regardless of what the base is, all the lateral surfaces are triangles. I don't think I actually explained what lateral surface is. The lateral surfaces are the ones around the side. So here's a lateral surface. Here's a lateral surface. It's hard to kind of draw the arrows. But those are lateral surfaces. And this is the base. Here's the vertex. The point where everything collides, there's the vertex. But those are both different types of pyramids. So if I was labeling this pyramid, this would be a triangular pyramid if you're being specific. This would be a quadrilateral pyramid. So you can be a little more specific with how you name them. And those are solids. And we're going to start to find areas and perimeters and different things like that of solids. But the last thing this lesson covers is what is known as Euler's formula. It looks like Euler's, but it's pronounced Euler's formula. That formula is V minus E plus F equals 2. Now what all those letters stand for, V is for vertices, E is for edges, and F is for faces. You would use Euler's formula to find the amount of vertices, edges, or faces in a polyhedron. So let's look at an example. Example 4 says, how many faces does a polyhedron with 12 vertices and 18 edges have? So we plug in what we know. 12 vertices plugs into V, 18 edges, so minus 18. We're looking for the number of faces, but they equal 2. So now we have one variable, and we can solve. 12 minus 18, negative 6 plus F equals 2. Add the 6 and you get 8. Well, you get 8 equals your number of faces. And that's how you use Euler's formula. But that's all we're going to talk about in lesson 49. We're going to start using solids though, and finding area, volume, things like that of those.